Hi, welcome again. This is video number 9 of our course Numerical Analysis for Computer Engineers, and today we are going to solve some equations. And as you remember, in the last videos, we have learned about how to solve a system of equations or a set of equations by using Gaussian elimination and then Gauss-Jordan elimination. But those are just linear equations. In this video, in this lecture, we are gonna handle with some equations which are harder to solve. For example, let's start with a very simple one. Let's say that we have an equation like x squared equals to 4. One can easily say that x must be equal to plus or minus 2, right? It's very easy to solve, so one can easily solve this equation analytically. But what if we have an equation like x squared equals to 5, for example? Then the roots are the solution of these equations. The roots must be plus or minus square root of 5. And then you should calculate the exact value of the square root of 5 by using a calculator or by using some programming language like Python. But you can find the value. But what if, let's say that we have an equation like e to the power of x minus square root of x minus x equals to 0. How can we solve this equation? Obviously, we cannot solve this equation analytically, or it's very hard to find the roots of this equation. So we should use a computer program to solve this equation. We should write some code to solve this equation, but also we need some numerical methods to solve this equation. We should apply some numerical methods to this equation to solve and find the roots of this one. So I'm gonna start with a Python 3 notebook again. So in my Jupyter notebook, I'm gonna create a new one. All right. So I have my Python 3 notebook, and I'm going to try to solve these kinds of equations. I'm going to start with the very first one, x squared equals to 4. So obviously I'm going to need some libraries, and as always I start with NumPy and import NumPy as NP. And also I want to see these functions, see these equations in a plot, in a graphical, in a visual representation. So I'm going to import pyplot from matplotlib splt. All right. And then I'm going to define my function and with the name f of x, and it should return. I just want to use the left-hand side of the equation, so we just need x squared. All right. Then let's define a NumPy array with the name axis, and x values, let's create them with the function linspace from NumPy, and let's say that they are between -5 and +5, and just with 100 values. All right. Let's create the plot. I'm going to use plot function with my x values and with my function. Let's show my plot. All right, we have this function. This is a plot of the left-hand side of the first equation, so it's just x squared. And if it's equal to 4, then it means 4 must be something like here. So then it means if we draw a line from this point, then it means we have, let's just use this color, we have this curve which is y equals to x squared, and also we have this line here which is y equals to 4. And our equation is x squared equals to 4, then it means we are going to search for the intersection points, right? So the intersection points, let's just use black. The intersection points, one is here and the other one is here. So we have our roots here. One is -2 and the other one is +2. All right. But what if we are going to search, we want to search for the second equation, x squared equals to 5. Then I'm going to change this line, right? Obviously, I'm going to need for a line which starts from here, x equal to 5. All right, and this is y equal to 5. So for the equation x squared equals to 5, we are going to search for the intersection points of these two. One of them is curve and the other one is the line. So the intersection points, one here and the other one is here. So we are going to search for these values. And first, of course, I just need to calculate the exact value for the square root of 5 to be sure for the value. So I just need a calculator. Square root of 5. It's x should be equal to plus or minus 2.230606 and 79775. This is our value. We are going to search for it. Okay, how can we find this value? By using a computer, by using Python. One thing we can do is just to try some values, right? We can start with some initial points, and then we can try another point or another point. This is the plot, right? We can use some approximate value. We can use some approximate value as for initial point. Let's say that this is 3 and this is about, if we just don't know the exact value 2.236, we can use just this value, right? 2.5, for example. Let's start with 2.5 and define a new variable, and let's say that it's x0 and it should be equal to 2.5. All right, 2.5, and let's calculate the y0 value. which is f x0, and then calculate the differences between 5, so it should be equal to 5, and this value, y0. All right, so our difference is between y0 and 5. And also I want to take the absolute value to find just the magnitude of this part. And let's say that this is D. All right, we have our values now. And let's print these values. Print, for example, y0 and then D. All right. With 2.5, we have our y0 6.25, and our difference is 1.25. And then we can increase our initial point, or we can decrease our initial point. We just want to move in one way, a positive way or a negative way. Let's try this. For example, let's use x1, and let's say that it should be equal to x0, and let's say that plus 0.1. I'm going to increase the value first, and then I want to calculate the new y value, which is y1, with this x value, and then I'm going to calculate the new difference, absolute value of the difference between y1 and our desired value, 5.0. And then I'm going to print y1 and D. All right. Now check the values. We have 6.76 as y1, and we have 1.76 for D, for the difference. Obviously, the difference now increases, but we just want difference should be less according to previous value. So obviously the sign here is wrong, right? The sign here is wrong. So maybe we should use D0 here and D1 here. I'm going to calculate these values again. And also we can take this line to here, and we can delete this cell. All right, we have these values. And in the third step, we can compare our values. For example, compare D1. If it is greater than D0, then what are we going to do? Then it means we are in the wrong direction. Turn to the other direction, right? Then let's define another variable and say that it should be, for example, it doesn't matter. Let's say that it's s, and it should be equal to -1. All right. That's just, I want it to be a real number. All right. Then s, now it's equal to -1. Then I'm going to repeat this process, but this time change the indices, y2, x2, d2, y2, d2, y2. But this time I just don't use the plus sign, but I'm going to use this coefficient. And it can be -1 or it can be +1, right? So let's multiply this step size 0.1 with this sign coefficient, like this. All right, let's calculate now. Then it turns to the other way, right? Now, but what if we just need to take the plus direction again? Then it means we just need an s variable and s initial value at the beginning of this calculation. So let's say that we have here an s and it's just +1. All right, and just don't use this absolute definition, but use a relative definition. What does it mean? Just multiply the previous value of s with a negative sign. All right, then it just changes the direction. Not just take the negative or not just take the positive one, but it just changes the sign of s. All right, it just do this. Okay, I'm gonna do this from scratch. So change the s value. All right. Obviously, it's a loop, right? It's a loop. So what is it? Obviously, it's a loop. So we just need this x0 value. You just need this one, x0 value. And then all the other codes should be in a loop. So let's do this. Let's do this. We just need this one and this part. All right. So let's say that for I in range, for example, 1 to, let's say that just 10, and calculate the value y for f x, okay, x0, and then calculate d. It's the absolute difference between y and 5.0. I just want to print these values, y and d. And also, if we have d according to d0, then s should change the sign. -1 times s. All right, we just need an s here, which is a +1. And also, obviously, we need a d0, right? We need a d0. Or we can add another maybe another condition, or just use a big value, a large value. For example, just use 100. All right. So I think it's all right. I can delete this part. Also, I can delete this cell completely. This cell. The The only one is I just wanna define x0 plus s times 0.1. All right. Good. Let's restart our kernel. All right. Now we have our loop here. What do we find? Obviously, we just need to write y values. All right, and it goes in the wrong direction. And also I want to see x values like this. And also I just want to see in a formatted way. So sorry. They are real numbers. Just use like this so we can see these values in a fixed width way. All right. These are x values, the first column. These are y values, and these are the differences, and it goes in the wrong direction. Why? So it goes to D0. Because we don't fix the values, right? In this part, we just change the values like this. Run again. Nope. D. Okay, this time it works. I didn't see it. This time it works because we just start with 2.5 and then goes into wrong direction, 2.6, and then it changes the direction to 2.5 and then 2.4, 2.3, 2.2, 2.1, and in 2.2 we just have this difference 0.16, which is the best value I think with this accuracy, and then it goes to 2.1, and this this process increases the value of d, so it turns into the other way, and it goes to this one. All right, the best value is this one, 0.16 with the value of 2.2. All right, but obviously it's not enough. What can we do to make this much more accurate? What can we do? We can decrease this step size 0.1. Let's try this. Maybe we can use 0.01. All right, then obviously it's not enough to use just 10 steps. All right, make it 100. Now we have our loop. Let's check the values. Check the values. we have our best value here, 0.0176. And this is the value of 2.24. It's obviously the closest value with this accuracy. Our step size is 0.01 with this value 2.23, sorry. All right, but obviously, as you can see, also if you want, we can see the I values by changing the format. So I just want to use 0, and there are just use 5D, and we should change these values now. 1, 2, 3, and I run again, and now we have our indices here, as you can see, and our x values, y values, and the difference. And let me check this. We have the value 2.24, right? So we reached this value with the step 29, and we give the value 100, so the rest of the loop is not necessary. So we can add additional check to our loop. If it repeats itself, it can stop. All right, let's do this now. Maybe we can how can we do this? Let me think about it. We can define two other previous x values, for example. Let's say that x00 should be equal to x0 for the initial value, and also x0. And this part is additional. It's not necessary, but I just want to write the codes. If I is greater than 3, because with the first 3 iteration, it will be equal to the same values. Yeah. If x is 0 equals to x000, then break. All right, it's correct. I think it's correct. And here it should be x00 should be equal to x0, and also x000 should be equal to x00. I will be very surprised if it worked. Let me run this. All right. If I think it should be at least 5. Nope. Because it always works. In this one, x00 let me show the values. Let me see the values. Prints x000, x0, 0, and x0. All right, we cannot change the value of x0, 0. Why? Let me increase this one. Which is the value here. This one is here. This one is here. So they are correct. They are correct. But this one doesn't work. x0, this one. If it's equal to it's a big mistake, right? So I didn't write in the correct. Obviously, time is too late and I didn't see anything. This is the correct one. It should be and. X, where is X? X0. All right. Yeah, now it works. Now I can delete this line and run again. Now, let me see how it works. This part and with the index 29, we find the value 2.24 with the smallest difference 0.017 and then goes to this direction and it starts to increase. The difference starts to increase and then change into other direction and find the exact same value with the previous value. So it stops. It works. Now I can increase the sensitivity. So decrease the step size. And I'm going to use 0.001. All right. And obviously it's not enough with 100 steps. So I'm gonna use, let's say, 10,000. Let me check this. Yeah. With the index 269, it would be enough to find the value 2.236. The exact value with the 3 decimal digits. So if you use this method, and we can call this method as brute force, for example, it's a very bad method and it's a very primitive method, but you can increase this sensitivity by decreasing the step size, and also you can increase the iteration limit for your loop, and you can run again to find the correct value. And obviously you are gonna need a good starting point. You are gonna need a good initial guess to find the root correctly. So we find now the value 2.2361. But what if we want to find the negative root? Let me decrease our sensitivity now to 0.01, and it doesn't matter because it will be stopped. It will stop, but let's use the number 1000 So let me use some other starting points. For example, let's just use 2, for example, 2.0. Run. And now it takes 27 steps to find the value 2.24. All right. And let's just use 1, for example. And now it takes 127 iterations to find the correct value. And now I just want to use 0. And now we have our point now, 2.24 again. I'm just curious about how can we find the value minus 2.23. So I'm gonna use this time -1 as initial guess. All right. Now we have found our negative root. Let's use -2. All right, this is good. Let's use -3. All right, this one is good. Let's use -4. We can still find our root. But I'm saying that it's the brute force to find the root of an equation. And it takes too much time when you want to get a really accurate value. For example, for 5 decimal digits or 6 decimal digits. Maybe it's not enough because you can have some specific equation, and it can be important. Just the integer part can be important. So you cannot use these methods in so many situations. In the next video, we are going to learn another method, a more successful one. See you in the next video.